Hi everybody, welcome to Lab Exercise 7.1 where we will be learning about the cardiopulmonary systems as well as human vital signs. This first section about the human respiratory system, what you need to do is scan this QR code. Once you scan the QR code, you will go to an interactive of the human respiratory system. You can click on each of these items and learn a little bit more, or you can use this list to learn where these different items are. For instance, if you want to know where the larynx is, you can click on larynx and it'll show you more about the larynx. But I actually prefer the 3D model. If you click on 3D model, you can click on the model and rotate in any direction or zoom in and then click on different items that you want to learn about. For instance, if I click here, I learn about the trachea and I can see and know where the trachea is, which is good because I need to label the trachea on my diagram. Make sure that you color and properly label this diagram because you do need to know these items for the quiz. So once you've identified a feature, color it in with your chosen color and then color the diagram with the corresponding color. The next section is about the human heart. Same thing, what I want you to do is scan this QR code. When you scan the QR code, you will be brought to a model of the heart where you can learn about all of the different structures of the heart. For instance, the aorta here. We can learn about the aorta, or my preference is to click on the 3D model and learn about the 3D model this way. For instance, if I click here, that is identified as the aorta. So we want to know all of the different structures of the heart that are listed. For instance, the left atrium, left ventricle, the aorta, the right atrium, right ventricle, superior vena cava, and inferior vena cava. Make sure to color these with the correct corresponding colors. For instance, the left part of the heart is supposed to be pink and the right part of the heart is supposed to be green. So make sure that you label those correctly because your patient is facing you, meaning that my right side is actually the left side of the heart and my left side is actually the right side of the heart. So make sure to keep those things clear. We also need to know whether the blood is oxygenated or deoxygenated and what direction it's flowing. So for instance, used blood that's deoxygenated is going to dump into the right atrium here, either from the superior vena cava or the inferior vena cava. Then it will be pumped into the right ventricle and pumped up through the pulmonary valve into the pulmonary artery, which will go to the two lungs. After the blood becomes oxygenated in the lungs, it will return to the left atria from the pulmonary veins here and here. They both dump into the left atrium. Then that pumps into the left ventricle, which pumps in with extreme force through the aortic valve into the aorta, which then delivers oxygenated blood to the rest of the body. Make sure that you know and have this memorized because you will need to know that for the quiz and the exam. Last is human vital signs. Now, face-to-face, you would be working with a team to complete vital signs. One person would be the patient, one the nurse, one the scribe, and one the supervisor to make sure that we follow instructions properly. But since we're online, let's just go through it, starting with blood pressure. Now, when you take a blood pressure, you will be given two numbers. The top number is always the systolic number. This is the pressure exerted on your blood vessels when the heart is actively pumping. The bottom number, which is supposed to be much smaller, is the diastolic number, and this is the pressure that your blood exerts on your blood vessels when your heart is relaxed. Here on this diagram, we can see some different ranges of low blood pressure, healthy blood pressure, and then high blood pressure. So let's go ahead and measure blood pressure. Okay, so we are going to take our blood pressure using a wrist sphygmomanometer. I'm going to secure it to my wrist using the Velcro and then press start. And hold it against your chest at chest level, making sure that your legs are not crossed. This takes quite a minute, but what it's doing is it's inflating with air, which exerts pressure onto my wrist. Now, it's sensitive, so it's feeling the blood pump against that pressure. As it's releasing air, it will be able to detect that pumping as soon as my blood pressure matches the pressure of the cuff. So we're going to get two numbers. We're going to get the highest number that it can detect and the lowest number that it can detect, which will give us that systolic and diastolic reading. So what we got was two numbers, 97 over 38. So the top number, 97, is the systolic number. That's the pressure when my heart is pumping. The bottom number, 38, is the number when my heart is relaxed. I'm not quite sure that that is the correct number, though, because this is an extremely low blood pressure. It's in the blue zone. Let's look at it. Okay, so what we have here is our blood pressure chart, and we're going to chart the systolic over the diastolic. So if I were to write 97 over 38, I would come here and look at 97, and then I would look at 38, which is not even on the chart. So my star would be somewhere right here. I don't think it's a huge cause for concern. I would recheck my blood pressure in a few days to make sure that it is maintaining this healthy level. Next, we're going to talk about lung capacity. Lung capacity is a good measure of your lung health. So to measure lung capacity, we're going to be using a spirometer. This spirometer looks like this. It has a dial on the end, and we want to make sure that the arrow is pointing towards 0. And then we need to get a replacement mouthpiece and place it onto the spirometer. Now, you have several different kinds of breath. You and I just sitting here talking, not exerting ourselves, we have the tidal volume, the normal volume of inhaling and exhaling at a normal rate. But if I were to vigorously exercise or take a deep breath, I'm no longer using my tidal volume, I'm using my vital capacity. So we're going to figure out what that is for me by breathing out. It's hard. Okay, so we can see here that my number has gotten a little past 3,000. And so we're going to fix the dial so that it is pointing at 0 again, and we're going to try it again. Okay, and we can see that now I've gotten almost to 4,000, so like 38,000 right there. And we're going to make sure that this is pointing at 0, and we're going to do it one more time. That time I laughed. And sure enough, we only got about 28,000 or 2,800, 2,800. So what does that mean for lung capacity? Well, let's see. If I had 3 trials and the first trial was 3,000 and the second trial was 38,000 and the third trial was 3,800 and the last trial is 2,800, what we're going to do is add those together. Add those numbers together. 3 plus 3,8 plus 2,8 equals 9,600. 9,600 divided by 3 is 3,200. So my average vital capacity is 3,200 cc's, so cubic centimeters of air. So this is my vital capacity. After that, we want to use the stethoscope to practice listening to lung sounds and heart sounds. So what you're going to do is use this diagram as a reference to listen to these different areas of the heart and these different areas of the lung. Now, this is very difficult to do for yourself, but we will try. So what we have is a stethoscope. I've already cleaned the earpieces, and we are going to place them in our ears. And listening to different areas, I want to give this a nice little tap tap to make sure that it's oriented properly, because there's a little gasket on the end and this piece turns, and when it turns it changes which side I'm listening out of, whether it's the small side or the big side. So when I'm listening to heart and lung sounds, there's some major points that we want to listen to. We want to listen to the top of the heart, the very bottom of the heart, and we want to listen to normal breathing at the top of the lungs, normal breathing at the bottom of the lungs, and then heavy breaths at the top of the lungs and heavy breaths at the bottom of the lungs. Now, people go to medical school for years to learn how to do this, so it's okay if we don't get it right the first try, but the point of the exercise is to get familiar with and listening to normal sounds so that when those abnormal sounds happen, you're not surprised by them. After we're done using this, we will use the alcohol swabs to clean the earpieces and the diaphragm of the stethoscope. All right, next is going to be heart rate and oxygenation after exercise. So what we're actually going to be using is a pulse oximeter. In order to take our pulse and our blood oxygen saturation level, we're going to use a pulse oximeter. It works best if you don't have any fingernail polish on, and I'm just going to clip it on the end of my finger and press the button, and we should get results fairly quickly. The top number is going to be my pulse beats per minute, and the bottom number is my percent oxygen saturation. So of the 100% of oxygen that can be saturated in my blood, it's 98% saturated. That's very normal. We should stay at 98, 99, maybe 97 at those levels. It should be very consistent. That top number is 93. That means my heart rate is a little bit elevated. Normal heart rate for resting is 60 to 80. 93, you're getting a little bit elevated, but that's because I've been speaking a lot and making these videos makes me a little nervous. So I'm not surprised that my heart rate is a little higher. Now in class, my lovely students were required to then do vigorous jumping jacks and see if anything changes. And what we would normally see is that the percent oxygen doesn't change very much, but the heart rate is going to go up with exercise up to a certain point. So let's look at this graph. In the graph, it specifies to draw a red line for the pulse, the beats per minute. So at 0, your beats per minute should be somewhere around 60 to 80. Mine was a little elevated at 93. And then after 30 seconds of jumping jacks, you might expect it to raise a little bit. After 60 seconds of jumping jacks, you might expect it to go up some more. But then after 90 seconds of jumping jacks, I would expect to see a little bit of a plateau. Connect those dots with a red line. And then it says to draw a blue line for oxygenation. So like I mentioned, we don't generally see much change in oxygenation levels unless there's something seriously wrong. So on this side, we see that 100% is at the top. So at 0 seconds, we would have a 98% oxygenation rate, and we should see that continue no matter how much exercise. So we should see a straight blue line up at the top. After completing, it's time to clean up, and I hope to see y'all next week when we go over the musculoskeletal system.